Okay, so now that we have the notion of a bound vector and a free vector, we are going to define a parallelogram. Now to start off, let's say we have 4 points in free space, A, B, C, and D, and we decide to join A to B, forming a bound vector. We decide to join B to C, forming a bound vector. We decide to join D to C, forming a bound vector, and then A back to D. Now, in terms of bound vectors and free vectors, what can you say? What's anything special that you see about this figure? This figure right here. Nothing. However, if we join up the points in such a way that A, B, C, D doesn't look down. A and okay, we'll go with that. A, B, C, and D. So we'll do the same thing again, join up A to B, join up B to C, join up D to C, and join up A to D. Now what I've tried to draw is these two having the same length and having the same direction. And so what we can say is that BC and AD represent the same free vector, K. Now, consequently, AB and DC must represent the same free vector. We'll call that T. And whenever we have 4 points A, B, C, D, and BC and AD represent the same free vector, we have a parallelogram. So if I tell you 4 points T, J, K, L, and I tell you that JK represents the free vector P, and TL represents the same free vector P, then TJKL is a parallelogram. Yeah. Now, notice that I've always said represents. I haven't written BC. I don't write BC is equal to K. There's two reasons. The first reason is because this is a different mathematical object to that. It's like saying 5 is equal to apples. The other reason is because if we was to say BC is equal to K, well, K is also equal to AD. And since this is equal to K, and this is equal to K, then from this, BC must equal to AD. However, how we've defined bound vectors as being different if they have a different starting point, if they have a different direction, and if they have a different length. AD and BC do have different lengths, but they have different starting points. They do have the same direction as well, but they just have different starting points. So this can't be true. BC does not equal to AD. The only way that this expression is ever true is if B is equal to A, which means that they have the same starting point, and C is equal to D, which means that they have the same ending point, which essentially means they are the same bound vector. And this is a parallelogram.